All right, so we're still on 12.3, and hopefully by now you've done some area questions like you've done in previous years. The second part of 12.3 is when you have two shapes together, and these are called compound shapes. And all you do is both of the shapes individually, and then you add up the two to give you the total area. So you need to familiarise yourself with shapes, which you would have done by now, so that when you see something like this, you can work out what they are. So hopefully this actually doesn't look like a rectangle, but it's supposed to, sorry, a square, but it is supposed to be a square. And we know that because of the double lines on each of these sides. So we have double lines here, double lines here. So if there's 60 metres there, it means there's 60 metres here. And obviously my diagram's not perfect because it doesn't look like a square, but it is supposed to be. Now, so we've got two areas here. The first area is our square. The second area here is half of a circle. And our half of our circle, the things we need to know, because the area of a circle is what? Pi r squared. So we're going to do half of the area of this circle. So we're going to do half a circle. So once we do half a circle and a square, we're going to add them together and we'll get the answer to this question. So let's go ahead and do that. If you want to go ahead without me, please do, and then look back in a minute. So I'm going to do area 1. And that's going to be 60 times 60. They're metres. So this is worth 3,600 metres squared. And area 2, we have said, is half of a circle. So we're going to do half times the circle. And a circle is pi r squared. So this is full circle, and this is half a circle. So we're going to have a half times pi times, in this case, if this is radius here, 60, then what is this half a circle? If the whole line is 60, this must be 30. So we're going to have half times a full circle. Half times pi times 30 squared. Okay, I'm going to use my calculator now to find that. Then I'm going to add them together. And jump ahead of me and see if you get the same answer.
Are you recording?
Yes, I'm recording. So the answer for this half of a circle is hopefully this, but I'm just going to double check that. Okay, yep, that's right. So the total area, so you need to write how I have area 1 equals area 2 equals total area is 3,600 plus 1,413.72, and your final answer should be, hopefully we get the same, 5,013.72 metres squared. Okay, now have a look at the next one I've done. And this one doesn't look like one shape with another flopped on top of it. In fact, something's cut out of this shape. So you have to think about it in terms of, we're going to change that. That should say millimetres, both the same units. Let's ignore this first of all. If this came down here, you would have a full rectangle. All right, and so we're going to call this area 1. I'm going to pretend we've got the whole rectangle to start with. Okay, so the first one we've got to worry about is going to be 20 millimetres by 50 millimetres, which is going to be 1,000 millimetres squared. Now, that would be if we have all of this, but we don't have all of that. In fact, we have this bit cut out. So when our first one was added on the top. This, in fact, is taking away half of a circle. So I'm going to call that area 2, and I'm going to take away what that is. So we have to work out what that is. And hopefully you've already cottoned on to the fact that it's, terribly drawn half a circle. And, of course, for area, we need to know what the radius is. If this is 20 millimetres, then this here is going to be half of that. So we have half a circle with a radius of 10 millimetres. And this is area 2. So let's work that out. Area 2, I should have put a 1 up here, is equal to 1/2 multiplied by area of a circle, pi r squared, which is equal to 1/2 times pi times our radius, which in this case is 10 squared. Now, obviously you can put that all in the calculator, but these are simple numbers, so I can just see what's happening. But please, feel free to leave out both of those lines and go straight for your answer. So we want, however you put it in, I put 50 pi. So 50 pi, let's go 2 decimal places, is 157.08, and it's millimetres squared. Now we haven't finished, but have a think about what we're doing. So the last one we had to add them together. So we did the rectangle, then we added half a circle. This time we're doing the rectangle. We're taking away half a circle. So there's our rectangle. There's half a circle. We're going to subtract. So we're going to say total area equals area 1 minus area 2 this time. So we're going to have 1,000. Subtract 157.08. Go ahead, find your answer. And hopefully you got 842.92, and hopefully on the end you wrote millimetres squared. So I think I've only set 5 or 6 of these questions because they do take a long time, all right? But you do have to kind of work out what is what. Now, I'm just flipping my page because I ran out of room to do the next 2. If you could please draw this, and then I'll explain what it is. All right, so hopefully in your drawing, you can see that one of these here is a what? Hopefully you can see it's a trapezium. Okay, so if I draw it again, I've got 5, I've got 2, and I've got a height of 1.2. But I got another one of those sitting on top. So you work out the area of the trapezium, and then you're going to multiply it by 2. So let's go ahead and do that. So I'm going to call this area 1, and that just means that 1/2 of it. So area 1, which is a trapezium, is our half A plus B times H, which is half times. Now thinking ahead of me, these are the 2 parallel lines, the 2 lines that will never touch. So hopefully you realise that that's the 5 and the 2. You can put 2 plus 5, you can put 5 plus 2, it doesn't matter. And we want to multiply by the height, which is the line that connects both of these lines. So it's 1.2. So in your calculator, you want to put 0.5 times, inside the bracket is 7 times 1.2. Okay, hopefully you got 4.2 millimetres squared. Missed my M down there. All right, now as we were saying before, that's just one of them. So far we've done this much of our diagram. There are 2 of them. They're exactly the same. They've just been flipped upside down. So total area this time is going to be 2 times 4.2. So your total area for this question is 8.4 millimetres squared. Okay, now I think it's question 11. Deals with, these are called annulus and annulus, probably annuli for plural, although don't quote me on that. And basically it's two circles. So think about a donut, and this question's talking about like the actual donut, finding the area of the actual donut. So it says calculate the area of the shaded region. You can see I've shaded the outside, okay? So you've got one circle with radius 5, and you've got another circle with radius of 10. Now, you can do both of those, all right, because you've done a few now. But you've got to work out how to get just this. So if you can have a look at it, if I was in class, I would bring in a donut or a ring of some sort, and I'd put my hand through the middle, and you'd say, we don't want the middle bit. Okay, we want the part that is actually, we can see and hold. Right, I'm thinking about one of those swimming rings perhaps. And to get that, to get this shaded area, we get the area of the biggest one and we take out the area of the smallest one. And that'll leave us with the shaded area there. So step 1 is calculate area of biggest. And that is obviously pi r squared, where in this case radius is 10. Okay, now you can put that straight into your calculator. We would have 100 times 3.14, so that's 314. Now actually, what is the 3.14.16 with 2 decimal places, and of course it's squared. Step 2 is calculate area of smaller ring. Now don't forget to pause if I'm going too fast. So we have area equals pi r squared, area equals pi times, this time our radius is 5, so it's going to be pi times 25. So our area equals, let me see, pi 25 is 78.54 centimetres squared. So have a think about what you've done. Okay, I realise it looks like a lot of working out, but it's not difficult working out. So we want the shade. We've got the big, we've got the little. So step 3 is going to be big circle minus little circle. No great mathematical terms here. Let's do it so that we understand. So our big circle was 314.16 and our small one was 78.54. Put that in your calculators. Beat me to it. You can beat me, go for it. And you should get 235.62 centimetres squared. And make sure you know what that is. You have found the area, or if we're thinking about a donut that you eat, it's the donut part. Okay, excellent. Now this, I believe, is question 11. All right, so come back to the video, come back to this example if you need to. Don't just not do them because they're question 11, which are the harder ones. All right, I'm not going to do these ones. I'm just going to talk them through with you, so you don't even have to draw them. Just have a look. How would you calculate the area of these? So these are, what are they? Say if that was 2, these are squares. So this would be 2 times 2 is 4, whatever that number is, but there's 5 of them. So you calculate 1, and then you multiply that number by 5. Okay, this one, area, looks really tricky, but it's really not. You are going to imagine that this here could actually sit inside there. So if this whole area, if you cut that off in a piece of paper, it would fit inside here. And what's happened is this question has actually looks impossible, has turned into just a half of a circle. And that's it with those two. I've just realised, I don't know what that is. I've just drawn it again. That's okay. All right. So the questions are here. Now, this is what you should have done already for the first part. And then this is your compound and a couple of worded questions. These are your circles inside of circle questions. And these are a couple of worded ones with diagrams. They're just the same as what you've been doing, but in a worded problem. So if you could get going with that, that would be great. Thanks, guys.